Good evening, everyone. I can see a lot of people have already joined in. Welcome for the session, everyone. Good to see you all here. I assure you it's going to be a Friday evening well spent. I'm going to introduce the topic, the speaker, in myself, of course, in a jiffy. I'm just going to wait for another 30 seconds for everybody to, because I can still see people trickling in. So I'm just going to wait for another 30-40 seconds and let everyone settle in. But once again, thanks and welcome to the session. I will meanwhile just go ahead and share my screen. If you guys can confirm that you can see my screen, that would be great. And I can get started. In the chat. You can just write yes. And yes, yes, thank you, thank you. I can see a lot of you write yes, great. I think let's start. I'm Niyati. I'm from Interview Kickstart. I have been working with edtech companies for the last 4-5 years and I have a work ex of almost 10-12 years now. And what in the last 4-5 years I've been doing is talking to people like you, talking to tech professionals across our country, and trying to understand. And I started off when AI was just a buzzword initially, but now it has become from a nice or good to have to a must have skill. And I've seen that transition. My conversations with you guys have been enriching, and that has helped me put together, be a bridge between industry practitioners and India's tech professionals to bridge that skill gap for you guys, and keeps me motivated every day. So without further ado, I'm going to introduce firstly the session. In between, I'll also launch a poll to understand you guys what is the expectation from the session, or what is your expectation from, what are your career goals. And of course, then I'm going to, much awaited, introduce the speaker. I'm very excited about that. So the topic for today, as all of you know, and that's the reason why you guys are here, is mastering RAG and building advanced solution with vector embedding and LangChain. So this is going to be a very detailed session, very enriching. We have done this in the past with tech professionals like yourself, and we have seen extreme amount of interaction and engagement. And the same speaker has actually run the session for us, and we wanted to do it for one more time because we kept getting requests to do this particular session. So happy to do this again. Like I said, we are going to cover a lot of things today. In between, so once I hand over to the speaker, I'm going to come back in between again and talk to you a little about Interview Kickstart. While some of you might know about Interview Kickstart, some of you might be wanting to know about us. So I'm going to get all of those doubts cleared. And then towards the end, the speaker is going to give us a small demo about the same topic. So before I get into that, let me launch the poll. Keep that on. And I think I'll have to stop sharing and then I'll have to launch the. Uh, Once I keep that on, I'm just going to launch it for a minute so that then I get into telling you guys a little about, like, I'll take 2 minutes to tell you about Interview Kickstart. But before that, I always like to know the audience. I always like to understand that, what is the reason you're here. And that helps us keep these sessions relevant and interactive, and so that you guys can keep coming back. Yeah, I can see a lot of you are already, I think 50% of you are or have already participated within 30 seconds. That's great. If everybody could participate, that would be super. Okay, so I can see that most of you are looking to upskill in agentic AI or Gen AI. That's great. This is the right place. This is, I think, the step one in that direction. Uh, I would later on take about 10-15 minutes to give you a more structured roadmap. I'll steal some 10-15 minutes from the speaker and give you that roadmap. Yeah, awesome. Uh, yeah, just I think we have quite a bit of entries already. I'm going to end this and again, go ahead, share my screen. Just give me a second. Sorry, sorry, just a moment. I'm facing a little bit of a hitch. Okay, I'm going to tell you while put the deck back on, I'm going to tell you about Interview Kickstart. We have been in the business of upskilling techies around the globe now in India and US specifically for the last 10 years. This is our 11th year. And we have particularly, we launched 11 years back in the US, in the Silicon Valley, started off by understanding the gap where people want to get into top tier tech firms and they are looking for some sort of structured pathway to do that. And we started off with interview preparation as the main offering that we have. And now we quickly, I think in the last 4 or 5 years, we have quickly understood that while cracking top tier tech interviews is one part of the game, the first part is to upskill yourself with the right skills so that you keep cracking the right interviews in the future, right? So our approach is not one and done, but to be with you throughout. We have about the secret sauce that we have is our the industry practitioners who actually set up and scale AI and ML systems in different FANG plus companies are our instructors. So we believe companies are the new universities, and whatever is actually happening on the ground, people like our speaker Surhid, they come to our sessions and teach our learners. We have a alum base of around 27,000 India and US across. And in India, we have seen an average hike after our programs. Learners have seen an average hike of about 23 lakhs per annum. So that's the kind of jump they are able to see and outcome they are able to see. Like I said, our secret sauces are instructors. That's the reason why we are able to stay in touch with what's the latest that's happening in AI, how people, how senior tech professionals are using it, and that's exactly what we are able to pass on to the learners. So we are trying to be the perfect bridge between what's happening on ground zero and giving you those skills right away. So without further ado, I'm going to introduce Surhid. Surhid is I can't think of a better person to take this particular topic for you guys. He's done this multiple times, and these sessions by him have been very insightful for the audiences who have joined in. He's currently the director of ML at Infinite Cooling, and which is a company in the climate tech space. He was previously in the ML team of TikTok, so that's the reason I said I can't think of a better person to take this particular session. He is also part of our instructor team, so you'll get a little bit demo on how our instructors are. So over to Surhit. I'll stop sharing my screen, Surhit. You can take over. Thanks for joining in. So over to you.
Thanks, Niyati. I'll start sharing my screen.
Sure.
Let me. Okay. Can everybody see my screen?
Yes, we can.
Perfect. Thanks. So thanks, Niti, for the great introduction. As Niti mentioned, I am currently a director of machine learning and Gen AI at Infinite Cooling. We use a lot of the things that we are going to talk about today in our production pipeline for climate tech related stuff. So we also do physics-based modeling, but we combine the physics-based modeling with machine learning and Gen AI. That's my current work. Previously, as Niyati mentioned, I was at TikTok where I was doing just more purely ML type of things. So um, today, I want to begin with giving a brief introduction to Retrieval Augmented Generation, or RAG as it is commonly abbreviated as. So what is Retrieval Augmented Generation? So in the era of generative AI, as you guys may have noticed, in 2 years ago or even 3 years ago, Microsoft Bing, for example, had this um, uh, events which we now refer to as hallucinations, right? Which is you ask a question to your language model or large language model, and the large language model comes back with a very reasonable sounding answer, but it's factually untrue. It's not grounded in any information. It's not grounded in any factual source of truth. So these type of events are known as hallucinations. How many R's are there in the word strawberry? And sometimes ChatGPT would also come back saying there are like some 2 R's in the word strawberry. So is that a correct English grammar answer to that question? Yes, it is. But is that factually correct? No, it's not. And so these are the types of things that used to not used to, but that can happen in any stochastic system, and LLMs by nature are very stochastic because they are a, probabilistically trained language models. And so the question becomes, given that they are very stochastic, how can we make them more deterministic? The opposite of stochastic is deterministic. So each time you ask a question, how can you make sure that the response is more and more grounded in some factual truth? The response is a high fidelity response. It has what we call as faithfulness. Faithfulness meaning, can we link the response of the language model back to particular source? How can we make sure that all of those things are obeyed? And one technique to reduce these hallucinations is RAG. There are other techniques also, which are like fine tuning the model, supervised fine tuning, and so on. But and there are pros and cons associated with fine tuning. Fine tuning requires you to actually train the entire model using your proprietary data, and requires a significant compute on the training side. RAG-based systems, on the other hand, you don't need to train the model again, but then you need to set up the memory infrastructure and this document resource infrastructure, which we'll see in the demo a little bit later. So those are some of the pros and cons, but at a very high level, retrieval augmented generation systems, or RAG, are essentially very crucial to ground your large language models with factual context. So, so as opposed to them hallucinating, you can instruct your language models to only answer the questions which the language model can search in, let's say, a database that it has maintained. So a key part of retrieval augmented generation systems is that these LLMs have access to external data, and typically we have these external databases. It could be a relational database like SQL, Postgres type of database, or it can be a non-relational database. Typically in RAG-based systems, we have vector store. Vector store meaning they are vector databases. What's the difference between a vector database and a relational database? I'll answer that question in a bit more specific manner later, but at a very high level, a vector database is able to store unstructured information in a very concise manner, and it enables very fast retrieval as well. So think about storing paragraphs or texts in a very compact, compressed format in a key value type of a setting. Those are the types of things that vector databases are um, they enable such type of storage. And so RAG based systems typically have access to these type of vector databases also, for us to for then that enables us to store these external documents that the RAG based system has access to. Um, and then these RAG-based systems are used for AI chatbots, assistants, recommendation systems, and typically these systems are used to keep a dynamic knowledge update to our LLM system. Imagine having an LLM that is pre-trained on knowledge up until December 11th, 2025. So if some new news comes today, should I be pre-training the entire large language model again just to incorporate this new piece of data that came today? Probably not, right? And so RAG-based systems, on the other hand, allow you to just keep updating this vector database with a new set of documents. And so these type of systems enable this continuous information update type of behavior. So, and as a result of that, RAG-based systems enhance accuracy. Why do they enhance accuracy again? What's a concrete example? An example meaning if I said something like, if I have a question about a very specific company process or a company document which is proprietary to my company, if I ask an LLM how to set up the VPN in my company, it might give me a very reasonable answer because setting up a VPN is a very common question and it might give me a very reasonable answer. But that answer won't be factual because that setting of a VPN is not something which which is specific to my company. It gave me a general answer. On the other hand, if I set up a RAG-based system where I upload my company specific documents and then use this vector DB to store them efficiently, you can actually get some concrete factual response specific to my situation. And so that is what enhancing accuracy here means. Dynamic knowledge, we briefly touched upon it on the last slide, where essentially I said if the language model was trained up until a certain point of time, you don't want to train the language model every single day. That's very expensive. And so you can keep on updating the documents in your vector store to reflect dynamic knowledge, and then domain expertise. So language models are known to learn this broad level structure of language. They are next token predictors, right? So they large language models learn the grammar associated with English language. They learn the subject verb object pattern of a sentence. They learn this next sentence prediction type of thing. They learn active passive voice. What's the definition of a verb? What's the definition of an objective, and so on. So language models don't learn the specific nitty-gritty associated with a particular domain. They just learn this higher level structure associated with the language unless they've been trained on the domain. So what RAG-based systems enable you to do is that they transform these general models into some specialized um, into a specialized model which has access to this key information that it can rely upon and then use its English language or whatever language understanding that it has been trained on to to answer your specific question. I see a lot of questions coming at once I'm done with keep them coming in the Q&A section at the lower part of the Zoom panel, and I'll take those at a natural stopping point. Hopefully that's okay. So let's understand. So the idea behind this RAG-based system is that a user asks a question that comes. So user in this case is us. We ask a question to our system, for example, how to set up a VPN, for example, in company XYZ. And before in a normal system, in a non-RAG system, this question directly goes to the LLM, and that LLM then just directly generates a response. On the other hand, in a RAG-based system, if a user asks a question, that question goes first to a database. This is that vector database that I was talking about. So this question first goes to the vector database. It retrieves the documents which are most similar to the question that I asked. How does it retrieve the documents which are most similar? We'll talk about that a little bit later using this idea called as embeddings. But it retrieves the documents which are most similar to our question. And then it takes our question and adds all of the context associated from those retrieved documents to our question. So now, instead of the LLM having access to just our question, now the LLM has access to not only our question but also these extra documents which are relevant to our input query. And then based off of that longer prompt with this enhanced context, the LLM is better able to generate a response. So one thing that and I think there were some questions around this also that I do want to point out is that RAG is just another set of, um, it's another method or another paradigm, if you will, which is used for enhancing the performance of your LLM from like faithfulness, fidelity, accuracy perspective. So one thing that can also improve the performance of your LLM is multi-shot prompting. Multi-shot prompting meaning you give examples within the prompt on what the answers should look like. Um, Agentic AI is a big thing these days. So agentic AI meaning whenever LLM has access to tools, in this case, tools meaning, let's say, let's say you ask an LLM, what is the weather in Bangalore? It might come with a very reasonable sentence saying that the weather in Bangalore is 28 degrees Celsius and sunny, without really without really knowing what the weather live right now is. And why was it able to do that? Because the language model was trained on a lot of different data where it knew that a English grammar construction with a what question should be answered, what and whether can be answered with something like the weather is 72 Fahrenheit in San Francisco. That's it. That might not be true. That might not be relevant, but that's a very reasonable answer that the LLM has given back. On the other hand, if you integrate that LLM with a tool meaning let's say a weather API, so you give this language model access to the internet or to the weather API, maybe it will input Bangalore December 12th weather and it will actually get back the live weather as of right now. And so tool integration is another way to essentially enhance this um, or reduce this hallucination and enhance the accuracy. And then providing additional context. This is what RAG based systems do. Additional context is something that we will be working with today. And these are essentially just different paradigms to improve the performance associated with large language models. And one thing that I want to note here is that all of these three methods can be combined with a retrieval augmented generation system. For example, you can have the LLM that you use in your RAG based system. That LLM can have examples within it. The system prompt can have some multi-shot examples. The RAG system that you are designing can have access to tools also beyond the vector database. That is known as agentic RAG, in fact. So we will be looking at a demo which is a simple RAG today. The the if you want to go a step further, there's agentic RAG, which is essentially just RAG with all of these extra web search, Google search, weather API, all of these different tools attached to your RAG system. And what all of these things do is they just provide additional context to your system. So the specific demo that we'll look towards the end essentially is we are going to create this knowledge base, which is this knowledge base about a company called Insurance LM. It was founded by Avery. We will have some information about the employees, about the products, about the contracts, and we will have some detailed docs associated with about this company. And as you can imagine, if you ask ChatGPT or some other LLM, which was never trained on data like this, it's not going to be able to give you factual information about company specific information. And so what we will try to mimic is essentially use the capabilities of these large language models and enhance them with this additional additional context using a RAG based system. Um, Typically, you prime your RAG-based system with something known as like this high-level system message. So whenever you have a LLM within your, so a RAG-based system, if you think about the architecture, has like a few key components, right? One of the key component is the input prompt. Second is the LLM. The third is your vector database, and that's really I guess that's really it. That's most of it, and then the LLM receives the response back from your vector database, and there's some output processing, maybe publishing it into a front end or something like that, but that's not a part of your um, LLM itself. So typically, when within these three different components, which is your input prompt, your LLM model, and your vector DB, your LLM model has a series of metadata attached to it. One of those metadata is a system level message, which is a part of every single prompt that the user enters. So that system high level message is that every single time a user asks that LLM a question, at the very beginning, the prompt is going to be like, you are an expert in answering accurate questions about insurance LM, which is this insurance tech company. Give brief, accurate answers. If you don't know the answer, say, I don't know, don't make anything up. So this type of prompt engineering at the very top of your RAG model is something that is also known to enhance factual accuracy and improve reliability of your RAG-based system. So that was a high level idea of RAG-based system. I've been talking about vector databases a lot, right? So I said that the three main components are your input prompt, your LLM, and your vector DB. So what are vector DBs? But before I talk about a vector database, I want to motivate the idea on why vector databases are useful in the first place and how exactly do they enable us to retrieve the most similar documents based off of the input query that we ask. So the vector databases rely on this idea called vector embeddings. Vector embeddings are nothing but they take your English or any language text, but let's talk about English in this case. They take your language and convert your language into a series of numbers or vectors. So imagine taking a sentence like the weather in Bangalore is 28 degrees C. Imagine taking this English sentence and converting it to some set of numbers like 0 0.1, 0 0.5, 0 0.8, 1.2, whatever it is. Con co- Imagine taking this English sentence and converting it into a vector. That is the job of an embedding model. So when you have a vector like this, for each of your words, each of the words in your vocabulary, you have a vector embedding. And based on this vector embedding, you can store this unstructured text. Now, because you have these vector embeddings, you don't quite worry about the relationship between um, which document did what, right? You just have a set of words and you have embeddings associated with them. And you just store that unstructured data into your vector database. And you can apply this same trick to images, to audio, to video data, and multimodal data. And all of that can be essentially stored in a some sort of vector representation. And then that gets stored into your vector database. Now, once you have this vector database set up using this idea of a vector embedding, um, they they form this real crucial piece in a RAG-based system because they enable our AI model to retrieve semantically relevant knowledge from our knowledge base. So, what does semantically relevant knowledge mean? So semantically relevant means the following. Imagine if I give you four words: mango, banana, apple, mountain. I think most of you can point out that these these four words can be broken down into two different clusters, right? Like apple, mango, banana can be one cluster, and this mountain can be another cluster. What I did right now is I essentially sorted them in a semantically relevant order. So essentially, I said all of these fruits should go in one bucket. That's my semantic, because they are semantically close to each other. And all of these other nature things like mountain, hill, mm, all of those things can go on this other cluster. So that's what semantically relevant means. And vector databases, essentially, because of this mathematical representation, they allow us to identify which things are similar and retrieve them. So tomorrow, when let's say I have all finance related documents in my vector database, and some of those documents have to do with taxes, some of them have to do with loans, and some of them have to do with um, insurance, let's say. Now, if I input a query, just like I did this fruit cluster and this nature cluster, imagine like hundreds of clusters done within the vector database. And now let's say my input question comes, which is tell me about some of the best car loan rates available. Um, this vector embedding method immediately lets me identify those documents which are in that loan cluster, such that only those documents are then appended to the input prompt. And so now my LLM has access to the exact documents that I'm interested in. So that's really the idea of vector embeddings. Um, Vector embeddings essentially are a complex mathematical representation of text-based, image-based, video-based, or audio-based, or multimodal, like a combination of both data. So they have like, imagine each vector having like a very high dimension. For example, like earlier versions of GPT, I think had 750 dimensional vectors. Now I think they have moved on to something above 1500 dimensions. And the input types, as I've been mentioning, can be a series of these multimodal things or some other abstract combination that you come up with as well. And again, the thing that this vector embedding lets you do is that it lets you ask question that it lets you ask this question, which is if I have words which are like if king and man are two similar words, what is the most similar word to queen? And then because of this vector representation, you can have this vector embedding logic. So essentially, a RAG-based system converts your query to this mathematical representation. It searches this vector database, appends your question with the documents that it retrieved, and then passes all of this information to the LLM to then finally get a response. Uh, Today we'll be building, there are a variety of different tools that you can use today to build RAG-based systems. One of them is LangChain. There's other code-based tools like LangGraph. There's some low code-based tools like Crew AI. There's no code based tools like Zapier, Make, and all of those tools enable you to build RAG based systems. Today, I'll be showing you a small demo using LangChain. LangChain helps you connect a variety of different LLMs. It lets you connect a variety of different tools. It has memory configuration for enabling continuity in a conversation, and it's a relatively modular tool that you can use to come up with a strong prototype. And so because it's a relatively modular tool, you can create a POC very quickly. It is used in production pipelines as well. So it can be used in standardized RAG workflows. It's not the LangChain provides you with a lot of abstractions, and so you don't need to worry about exactly which language model you are using. They have model agnostic wrappers, and so if today you want to use GPT, tomorrow you want to use Claude, you can do all of those swaps very easily without changing a ton of code. And their APIs have matured, and they are still maturing every single month. They have their own pipelines that they roll now, and if you build something with LangChain, you'll know pretty much all of the important pieces that are required for you to assemble a RAG-based system. So one thing that LangChain also enables you to do is they have this document loaders package associated with them. And what that enables you to do is you don't need to worry about uh, deciphering the text from a PDF document or like worrying about the structure of a CSV file. They have a variety of different file formats in their directory loader, including images. And so you can take all of those data loaders directly, tag those things with your specific information that you think that you want to add to your specific documents, and then create those document objects that eventually you want to store into your vector databases. Um, Another thing that is important in a RAG-based system is what we call a chunking strategy. Essentially, you don't take your document and store all of that document as one giant piece of text. You break that document. Let's say if it's a 1,000 pages document. Maybe you want to chunk um, each page one by one. Maybe it's a piece of code, then maybe chunking by a fixed length doesn't make any sense. Maybe you should be chunking by like some specific keywords that mark the beginning or end of a function and a return statements. So chunking strategy essentially determines how you are breaking up your documents and passing them to this vector database. And chunking essentially creates this semantic context within your database. So you have for creating these chunks, for creating these embeddings, again, you have state-of-the-art models from Anthropic or OpenAI or from Google, where essentially you are taking these documents and converting them into that vector embedding representation that we talked about. We will be using OpenAI embedding model in our demo. And again, what all of these methods let you do is that they let you capture this semantic meaning associated with the sentence. So in our documents case, as I mentioned, it's able to take all of this natural language, pictures, images, words, audio, and cluster all of the documents with loan information in one cluster, with some other information in a second cluster, with some general product information in a third cluster, and so on. So that's essentially the intuition behind vector databases. To be a little bit more concrete on which providers exist there that provide us with APIs for setting up a vector databases. Chroma DB is one such supplier. They have a vector DB which comes with very simplified APIs. So it's very all of these things of like converting your documents into these mathematical representations are all abstracted away from you. So there's pros and cons to this. The pros is that you don't need to worry about what happens underneath the hood. A little bit of the thing that you may want to be aware of is that because you don't quite have access to what happens underneath the hood, you have to make a little bit more effort to understand the operations underneath it to make sure if something goes wrong, you are well equipped to debug. And so all you need to do to set up these vector databases is some simplistic, relatively little code. And this is what I was mentioning. Once you have all of those documents set up in your vector databases, you can ask questions to convert those documents into semantically relevant things. So, for example, in a large piece of text, which are the things that are adjectives, which are the things which are nouns, which are the things which are verbs, and so on. In a typically, we wouldn't quite structure our vector database as verbs or nouns or adjectives. We use more human readable or human interpretable clusters. For example, maybe in our insurance LM thing, maybe we ideally want one cluster of documents to represent some HR records about employees and some personal data. Some other cluster should represent some company specific information. The third cluster should represent some contracts. The fourth should be some products associated with the company and so on. So Chroma DB is one such vector database. FAISS, the Facebook AI similarity search, is another such vector DB. Pinecone is a third one. Qdrant is another one that I know, and there are many players in the industry. But the high level point that I wanted to just make is that all of them have a very similar API, very similar code structure. And once you have your vector DB set up, LangChain can LangChain can take that vector DB, and you can swap this vector DB with a Pinecone, Qdrant, Chroma DB with very minimal changes to the code. LangChain doesn't care about which vector DB you use as long as you have some vector DB set up and you pass that in to your RAG-based system. So, right. And so switching, this is what I was trying to mention earlier. So that's the power of abstraction, that you don't need to worry about which exact vector database you're using because that has been abstracted away for you. Niyati, do you want to take this one over?
Yes, I will. Thanks, Surhit. I'll go ahead, share my screen. So,
Yeah.
guys, we are going to give Surhit a little bit of a break. Surhit, what in the meanwhile you can do is there are a couple of questions in the Q&A section. You can go ahead, type out your answers.
Okay.
A lot of people have actually posted their questions in the chat. I have put them in a doc so that towards the end, once your demo is done, we can go through them. Whichever you have not answered, you can answer. But meanwhile, if you can answer some in the chat or the Q&A section, that would be super.
Okay.
Cool. I'll go ahead and share my screen, Suraj. Thanks.
Thanks.
Okay, so I'm gonna take 10 minutes, guys, and I'm going to give sort of a little bit of break, like I said, take you through why Interview Kickstart is doing this particular session, what are we, and how we can help you. So my guess is the fact that you're here, and I hope you can see my screen. So if you can just confirm that quickly.
Yeah.
Super, thanks. Uh, so we know for a fact that if you're interested in a topic like this, you are most probably looking for something more structured and more detailed. A lot of you are already asking in the chat that a lot of questions that I'm seeing are primarily answered in all of our sessions in our programs. So I'm going to take you through that. But why am I taking you through that is the question that I'll first answer. In the last 2.5 years, what we have seen is what started as an interest of into LLMs, thanks to ChatGPT, advent of ChatGPT, from prompting to now it has shifted to building, right? And whereas these skills were initially good to have, they have now become must have. Like I said, while 2025 was a year where you could dabble into it and show some projects which are making a little bit of a dent or moving the needle a little bit. A lot of you are now expected to in the year from 2026 and onwards to work at a level that Surhit is already, for example. We can see that in the jobs that are available also in India, and this is LinkedIn data that we started tracking from Q1 of 2023 till about Q3 of 2025. So you can see across full stack, Android engineers, AI/ML roles, data engineers, for engineering managers. So I'm talking about roles right from ICs to mid ICs, senior ICs to tech leaders. There has been an increase of jobs, and a lot of it is led because of AI, right? Powering AI, powering all of these roles across. Uh, that has not just led in the increase of jobs in the market, but this has also impacted the salary that you take home, right? So, and you can clearly see the gap that it keeps on increasing for somebody who's a traditional engineer, quote unquote, to somebody who is an AI enabled engineer, right? And in it, for example, let's look at the IC ladder. The impact of the salary by the time you hit about L6, L7 level, where most of our learners are from, the impact goes from about, the difference goes from about 10 lakhs to 35 lakhs per annum. And that's a huge difference. This is, and this data is about, I think, Q2 2025. And I'm sure this is just going to keep on increasing. Uh, what we did, we actually scraped a lot of jobs on LinkedIn and started seeing, okay, where in which kind of roles AI as a skill is needed, where has it become like a essential already, and where is it that it's already growing, right? So tech product managers is something that's topping the chart. So 45% of them require or have the requirement of AI skills in their opportunities mentioned, in their job descriptions mentioned. And a cloud solution architect, engineering managers, data engineers are not far behind. It's all 30-40% plus, which is I think by the time this time next year, I'm going to give this presentation, this will actually go 60% plus in a lot of these roles. So is it something to be scared of? Not at all. I think because there is a structured part available for you that I'm going to talk about. If that fits you, super. If you still have doubts, talk to us. You all have career advisors, program advisors aligned to you, and talk to them about where you are in your career, what is your need, and what kind of AI skills do you even need, right? Uh, while and why do I say talk to them? How do we know what kind of AI skills are there in the market that are needed by hiring managers? We, going through the requirements of hiring partners is what we do day in and day out, and we keep evolving our programs accordingly. So, just an example on your screen is software engineering already, and this I think I took at the start of this year. I took this snapshot. Software engineering roles, for example, in LinkedIn and Microsoft, already have the mention of AI ML integration in their job descriptions. Okay, and these are obviously, you can see these are screenshots I've taken from LinkedIn about actual live roles. And that's the reason why there is so much importance, and I know that's the reason why you guys are here in this session. Uh, while that is important, a lot of times what we hear in our webinars is people don't know where to start, and that is a challenge. And I think that's a very human challenge, that I don't know what is the right path, what do I start with? And there's some people, there's already too much happening. I don't know where to enter this AI upskilling roadmap. Where is the point I actually inject myself into it? Don't worry about all of those. So we are here to solve all of those doubts. I'm going to give you three roadmaps in front of you. I'm sure uh, I one of the three will be applicable to you. Okay, so we have a transformative Gen AI track where in your current domain, whatever is your current tech stack, we are going to help you add a layer of AI skills on it. Okay, and as per your domain. So if you're a front-end engineer, your journey is going to be very, very different. If you are a technical program manager, your journey is going to be very different. Okay, so we understand that we are not going to give you a straight-jacketed, a generic program to follow. No, we are going to give you different pathways. There are about 18 pathways. Okay, so it goes in that much customization and that much depth. Flagship machine learning is for people who are looking to get into AI intensive roles. So if you're a software engineer, or if you're a DevOps guy, if you want to get into ML ops, and software engineers, if you want to get into ML engineering roles, this is a perfect program for you, right? So I'll take you through a little bit of what the program is about. And the third, I feel, is relevant to any. So if you feel the first two are not the buckets that you fit in, the third one, I'm absolutely sure you will fit into it, because this is basically, and I can see it from the questions itself. A lot of you were talking about agentic AI. This is where uh, working on this is a project led program, like fully project. While all of our programs are project led, this is less theory and all projects. And we have partnered with PwC on this, where they have given us Gen AI projects, agentic AI projects from their Fortune 500 clients. Okay, so they're from different industries. So I'll take you through that also. All of these three have the element of interview preparation of about 3 months across, right? And that's the product that has been running for 11 years. We've been doing that with almost 30,000 learner base now. So that's the benefit, but where we give in each of these programs, in each of these tracks. So transformative Gen AI, let's go through that. Like I explained, it has 18 different tracks, and it can be customized for you wherever you fit. So if you're a test engineer versus a data engineer, whatever, we are going to make a separate path for you. Okay, we are going to teach you AI skills that are relevant for you. Okay, we are not going to teach you so you don't waste a lot of time. You focus on what is required by your role, and the value that you get out of all of the time that you spend, because we understand that you're busy working professionals, you have families, you have a life beyond all of this, and you still want to, still serious enough to actually upskill. So we want to also make it worthwhile for you, and hence the customization, right? uh, I'm going to give you an example of an SWE module that we have, that we run in transformative Gen AI specifically for software engineers. It's different for different roles, and your program advisor can take you through it if you're interested. So the first part, which is just the Gen AI upskilling, is for 14 weeks. You can go through your Python basics, a lot of engine, because like I said, we cater to a lot of senior folks. They sometimes just want to brush up their Python skills. And then you go into building foundational AI agents, then getting into building of advanced AI agents, and then finally deep diving into what's specifically made for your domain, right? LLM architectures and everything made for your domain. So you get into that. Uh, Similarly, the second track, right, is flagship machine learning program, which is the first part of it is 6 months, where you go from, again, we start with Python basics. You can skip it if you have Python basics already set in. That's great. You join us in month two. You go from classical ML to deep learning to Gen AI, agentic AI learning, building of neural networks and architectures, and then like I said, we also have specializations in this. I think there was a question also by someone that I want to understand computer vision. This is the program for you. So I told you I'll answer it for you in towards the fag end of the session. This is the answer. We also have specializations on advanced NLP, advanced computer vision, like I said, MLOps, big data with Apache Spark, and you can choose any one of them and take forward your journey. Towards after the 6 months, the 4 months are spent into interview preparation. And I'll tell you what we cover in interview preparation also. Just this is a snapshot of what I've been talking about, project led, right? Like I've been using this term a lot. Here's the reason to believe why our approach is project led, right? Our projects are not toy projects. Our projects are not old data sets that you actually just submit in a Word doc, tell the approach. That's not how you submit it. By the end of it, you have a working production ready project ready. Okay, that can actually help you build your e-portfolio, showcase it to your either your own company manager or different hiring managers or anybody, right? Or even showcase it on LinkedIn if you want. So you go through different projects, you actually cement what you're learning in theory, right? The last bit, like I said, could be applicable to anybody, is the agentic AI accelerator that we have with PwC India. There, it's a 12-week program where in the first 4 weeks, you are going to go through a little bit of agentic AI fundamentals because it's still new. When I say new, it is a few months old only, I know that, but still new for a lot of people. People still have a lot of doubts. You learn about different tools that we are going to use, MCP being one of them, which is actually not available in the market as of now in different programs. You can actually come and use MCP orchestration over here, and build projects. So in the fourth week itself, you will have an AWS deployment of the first project, mini project that you build. And from week 5th to 12th, you will actually have capstone projects that are from the industry. There are in enterprise grade projects in healthcare, BFSI, e-commerce, and supply chain. These four industries are using AI to the maximum right now. So if you do these projects, you can either do one or all four. That's dependent on you. And build agentic agent systems in these industries and actually showcase it to your hiring manager, right? In this program also, with this program, you can take the interview prep lab modules. This I've explained. What are the four projects? If you want details, you can actually talk to us. We are going to, as it is, give you a call after the session to get a feedback to help us understand that where are you in your career, what is your goal, and if we can be a partner in that, that would be great. This is the interview prep lab that I've been talking about. These are not vanity sessions. These are 3 month, deep dive sessions where you get mock interviews with people like Surhid. So, for example, if you're applying for an engineering manager role, you'll have a mock interview with Mang Plus practitioner who is an engineering manager or above in top tier tech companies, right? In the first two programs, which is Transformative Gen AI and Flagship Machine Learning, you have about 15 available. And in Agentic AI, you have about, I think, 10 available mock interviews. In placement assistance, we tell you how to optimize your LinkedIn, your resume. We take you through behavioral rounds, what happens in that. And we also help you in offer negotiation. In the IP, the interview preparation modules, we also take you through the basics of DSA and system design. So anything and everything, not just about AI, but even the basics of what a tech interview is based on are covered. Okay, so you can be rest assured that this is a end-to-end assistance that we are giving. As far as placement assistance is concerned, we already have about almost 200 hiring partners in India now. And these are the partners who hire our learners from different levels and for different domains. All of these are obviously referral based. This is the last slide that I'm going to show you about the cost outlay that you have to give to enter any of our programs. Transformative Gen AI with the interview lab starts at 1.5 lakhs, goes up to about 2.8 lakhs. This depends on the domain that you're from, because like I said, it's customized, so it's different for different domains. The flagship machine learning program is about 3 lakhs. There are obviously scholarships available across, so you can talk to your program advisor if you're interested. The Agentic AI Career Accelerator by PwC India and the interview prep lab starts at about 2 lakhs and goes to about 2.8 lakhs, right? We have EMI options available, of obviously scholarships available in the first two programs, Transformative Gen AI and Flagship Machine Learning course. If you successfully complete the program and the mock interviews, we also have a 50% refund available if after the support period you're not able to find the transition that you were looking for, right? Uh, Now, before I hand it over to Surit, I'm going to launch a very small poll where I want to know that if you're interested to understand which program is relevant for you and take a structured approach to upskilling in AI or ML or agentic AI, right? Like most of you are interested in, let me know and we will get in touch with you. So there's a poll right in front of you where it tells us that you want to know about a program, right? So go ahead. I'll keep it on for about a minute or so and happy to take it forward. And I think I'll just, sorry, I'm going to just take 1 more minute and till the poll gets over and then you can start off again and show the
Sure.
demo. The demo is coming up, guys. So super excited for that. Yeah. Sorry, you can go ahead actually.
Okay, so right, so hopefully you guys got a good overview from Niyati on what are the different types of courses and offerings that we do. A lot of the questions that you guys are asking in the chat are actually, we go through each and every one of those topics in quite a bit of detail in our courses that we take a deep dive on over a set of 10 weeks or 12 weeks or however long that particular cohort runs. So right. So let's get back to our RAG-based design that we are talking about. So some of the main, as we mentioned, there are quite a few topics associated with, or a few main components associated with RAG-based systems. So one of them is an LLM. The next thing is this vector DB, and the third thing is one thing that you can add in your RAG-based system for like a continuous conversation is memory management. So it keeps on remembering the previous history and the chat history that you have interacted with, and so there's like a certain level of continuity to your conversation. So, and typically in LangChain type of systems, what, as I said previously, a lot of the stuff is abstracted away from you. So you need a few key components: LLM, some vector DB, and memory. So you need some LLM. In this particular case, we are using GPT-4 Mini, but you could very easily use some other model that you want to use. Your code would look very slightly different, but you just need one LLM here. You need, if you want to add memory, LangChain provides you with like conversation buffer memory. There's also conversation memory. There's conversation summary memory. There's conversation window memory. There's different types of memory management associated with LangChain and its tooling. We go through those as well, and different types of LangChain and LangGraph and LangSmith, and pros and cons of each in our regular classes. Finally, we have this vector DB. We set up this Chroma vector database, remember? So that was our vector DB that we are using. And finally, our chain is all of these things: the LLM, the retriever, and the memory, all stacked one after the other. And this last line here, the conversational retrieval chain, is something that is not going to change. All of these modular pieces, the LLM, retriever, memory, can change as is. And what that does is that because of this modularity, because you have this LLM and the retriever in your chain, some very small spelling mistakes are okay because we are not using some keyword or string match to retrieve the information. We are using this semantic matching, and semantic matching is more robust to spelling errors. Um, it's more robust to lowercase, uppercase differences. And then it can also, because of memory, it can also add continuity to the conversation. So, what did she do before? What does this pronoun she refer to? And our system correctly identifies that it refers to this founder person. Um, Typically, LangChain-based systems are configurable in this declarable YAML type approach. I don't know how many of you have heard of YAML files for setting up configurations for databases or even for general software microservices, but YAML-based files typically have a very structured format. LangChain type of RAG pipelines follow that format as well. And it's quite modular, it's quite powerful, preferred by a lot of developers, specifically for early and fast iterative development because of its flexibility and familiarity. So right. And we have talked a lot about just RAG-based systems, some theory associated with it. But one thing that we didn't quite touch upon is what to do with if your system fails. How do you know which part of the system to debug? And so there are methods for you to set up logging. There are methods within LangChain for you to set up the stack trace. And the stack trace in this case essentially means you are able to go under the hood and see what prompt got passed to the LLM, which documents were retrieved, where exactly did the chain fail? Should you be improving the retriever? Should you be improving the prompt? Was the problem with the LLM itself? You can do all of those things within the LangChain ecosystem itself. Um, some of the very common problems that are associated with a RAG-based system is that the the chunking strategy is wrong, and so the wrong chunks are retrieved, and because the wrong chunks are retrieved, the input query and your chunks don't even match, and the LLM is not, or the RAG-based system is not able to give a particular response. And LangChain essentially enables you to let you peek under the hood, if you wish. So typically, once if you identify that the retrieval strategy was wrong, or if like this chunking was maybe the retrieval strategy was wrong because the chunking was done in a very coarse manner, and so what you need to do is maybe increase this chunking count, and so send more pieces of information to the model than just like this one small little paragraph that you're sending to your input prompt. Maybe you can make decisions or hypotheses like these because your LangChain enables you to let you peek under the hood and set up this logging and stack trace to make sure what is going on under the hood when you're actually calling this LangChain API. You don't need to understand or code from scratch all of this vector DB and embedding framework, but LangChain still gives you the ability to peek into what's happening underneath the hood. Um, And again, whenever you're making these optimizations in the RAG-based systems, there are trade-offs. So larger the context size, you have better information coverage, more comprehensive answers. But because your prompt now is getting longer and longer, your latency suffers. So when your LLM is producing a response or a RAG-based system is producing a response, you're going to take more time to just get the final answer back. It also incurs a higher cost to run the model because you are using up more and more context, more and more information. Um, and so there's a lot of different hyperparameters that you need to set up. So like all of these parameters, like what is the right chunking strategy? What's the right chunking size? Which is the right LLM? All of those are hyperparameters. And hopefully you saw in that little code snippet I showed you and in the demo as well, you will see that it's very easy to swap out and change these hyperparameters and change these LLMs. And that's really the point of LangChain based system because they introduce this type of modularity. Um, you can go beyond these simple techniques. You can combine your vector similarity search with some traditional keyword search. You can use your own, once the documents are retrieved from the vector DB, we can essentially introduce some ranking strategy. We can input our own domain knowledge to claim which documents are the most important versus which are a little less important, and you can generate you can combine the first 2 points to your input prompt as well to expand your query to improve this retrieval knowledge. So with that being said, let's take a quick look at the demo. I'll share this file with the operations later once I remove some API keys, but I just wanted to show you. So as I mentioned, we are going to create this expert knowledge worker. This expert knowledge worker is nothing but this knowledge worker is going to store information about this insurance LM company, and our agent needs to be accurate and it should be a very low cost solution. So we will be using a RAG, a very simple RAG based system. So what is happening here is nothing but just installing some basic LangChain, LangGraph packages, and then I have just mounted my Google Drive because that's where I've stored all of the documents. So all of these documents associated with this company are stored in my Google Drive. I have imported some of the key packages in LangChain. So as I mentioned, this directory loader, text loader essentially are just document loaders that loads different folders, different text that we pass to those. Um, these OpenAI embeddings and chat OpenAI essentially gives me the embedding model and the access to GPT models from OpenAI. Um, Chroma gives me access to this retriever or the vector DB that I'm going to set. And as you can see, LangChain Chroma is one package that I'm importing from. If I wanted to do something different, maybe I can do LangChain files, right? This is another thing that I can use if I wanted to use Facebook AI similarity search. Nothing is stopping me from using this one as well. It's just that it was my decision to use Chroma. Maybe some of you decide that Fies is a better one to go. Very easily doable. These are just some basic native Python um, imports, and then we are going to create a conversation buffer memory that just keeps a track of previous conversation that we are having with our bot. And these are just again embeddings that we are going to use. So we first set up our model, which is this GPT-4o mini. We set up our API keys. We load all of the documents in we take the documents from our knowledge base here and load all the information from those documents into this variable documents. Next, what we do is we take all of those documents and break them down into chunks. So let's see if, so you see, these are all of the documents that I have, these HR records for like different companies, the platform updates, some other company specific information, some compensation history associated with different employees, and so on. So I have all of this, and then you cannot pass all something something like performance optimization is very different in information than something like business opportunity, and that is very different than like some HR record and personal information associated with with the employee, correct? And so we need to have a way to store them and cluster them, going back to my example of apple, mango, banana, and then mountain. So like our mind very quickly clustered them into different clusters, right? We want to do something similar with this type of information as well, because that will make the LLM later on retrieve these chunks very quickly. So we want to like sort them in a reasonable manner. So that's what this embeddings will enable us to do. And what um, chunks, let me go back here. What these chunks let us do is essentially we have broken down all of our documents into some sizable amount of text as opposed to passing it the whole thing. So chunks essentially means nothing but just breaking up large set of documents into like smaller pieces. And how do you exactly chunk? What are the different chunking strategies? There's a whole lot of science and an art to this, but we have done a simplistic chunking strategy where essentially we take the first 1,000 words, call them as a chunk, then take an over like so we take the first 1,000, like the first chunk is the words 0 to 999. The second chunk is the words um, 699 to the next 1,000, and so on, because we want like a certain amount of overlap. You use this overlap so that you again don't lose information when you are splitting up this document. So that's what our chunking does. Once you have our chunks set up, the next thing that we do is we want to convert these chunks into embeddings. Remember, I said those vector embeddings thing, which makes you answer questions about which words are similar, which words are different. So here I've set up those embeddings. We have used OpenAI's embedding model. And with that embedding model, we are going to initialize our vector store. So our vector store takes those chunks, takes those embeddings, and we just add our name just to make sure we identify it correctly. And so it's created this vector store with some 413 documents. These were the same amount, same number of documents that we had previously here, 413. Once we have the vector DB set up, the next thing that we need to do is just set up our vector store. And so once we have all of those set up, let's visualize what we have so far. So these are the vectors that we got. These are the vectors from our embeddings essentially. And what they typically look like is the following. So you see what has happened here is the following. We were based on the vectors and the mathematical representation of that information, we were able to cluster them into some groups. And let's see if we can see some commonality between those groups. So all of the green dots here are the employees, right? So all of the text associated with the chunks associated with these green dots represent some employees, compensation history, annual performance history, rating, and so on. Similarly, these red dots are contracts associated with our insurance LM company. These blue dots are some products. These yellow dots are some company specific information, and so on. And so those are the types of things that you can do to and I was able to do that because essentially that gave me that I think only two it's a 2D graph, that's why. If I wanted some 3D graph associated with the same information, I can do something similar. So here there's maybe a better representation of those yellow dots and then how they are similar versus some of the red dots. And once I have all of these different pieces together, the next thing that I want to do is just combine all of them together, right? And this is where we are setting up our RAG-based system. So all I'm doing here is taking up one LLM. As we mentioned, we have our GPT model. Then we have added some memory to add continuity to our conversation. This is optional. You don't need to. This will run even without this argument. We have set up our vector DB. We are using Chroma, and that Chroma DB is set up in the store, vector store. This is our Chroma DB, right? You could have very easily switched this out with Pinecone, Qdrant, or anything else. The only point is that you will just have to create that specific retriever, pass that retriever to our conversational chain. This is again that abstraction that has been introduced to you from LangChain. And now you can ask a specific question, right? So which is this, what is Markel LLM? Markel LLM, I think, was one of this product. See, Markel LLM. It's a innovative two-sided marketplace designed to do something to connect with the customers and so on. So let's see what our thing says. See, so Merkle was developed by insurance LLM. Is an innovative two-sided marketplace designed to connect consumers with insurance companies. It features user-friendly interface, and this is exactly what our document also said, right? It connects consumers with insurance companies and so on. Let's try something else. So if we go to employees, and if we go to which one do you want to pick? Let's pick Priya Sharma, I guess. So let's see if it's able to answer something specific about this employee who is See, in senior data scientist, January 8th, 1986. Is that true? January 8th, 1986, senior data scientist, and so on. Salary 145K. All of this information is retrieved because this information was there in our vector DB. Who is the founder of Insure LLM? And so we get answer, which is something similar. And because we have also set up this memory aspect of it, there is one thing that I wanted to point out, and I'll just maybe show it through the demo. Um, who is the founder of Insure LLM? The founder of Insure LM is Avery Lancaster. Uh, what does she do? So how did my chatbot know that this she refers to this question? It knew this because I have added this memory context to it. I've added this memory context to it. So it periodically retrieves the previous chat history, and you can set up certain parameters on how far back it should go exactly. These are all the details. I'm skipping a lot of details in this talk. Typically, this is the type of material that we cover in a 4-hour class. And so we go through each and every piece, and we try to go through each and every aspect of what LangChain gives you, how to start thinking about LangChain, how to like start thinking about which components to set up and when, how to evaluate these things. But this essentially is what I wanted to cover today. And so, and as I mentioned, typically you can also have this stack trace or visibility into what is happening behind the scenes when you're calling LangChain. So we essentially had this system prompt, right? Our system prompt was like, use the following pieces of context to answer the question. Just say, I don't know, don't try to make up an answer. Um, and so this is the prompt that was passed. These were the documents that were retrieved. And then based on something like that, it answered the question. So, for example, what is the weather in, let's see if maybe it will answer because it has access to an LLM. It says, I don't know. So you see, this is it didn't answer this not because it wasn't a reasonable question, or because it could have faked an answer here, right? It could have faked an answer, but it said, I don't know, because we instructed the model to not hallucinate. We instructed the model um, to not make up an answer in our system prompt. So who is describe some contracts associated with insurance? So you see, if I'm talking about the contract, it has retrieved some information about these contracts. So contract with Metropolitan Life, contract with some other thing, and so on. So these are the documents that it retrieved, and you can see what exactly happened behind the scenes. So that's really all that I wanted to cover today. Let me go back to this. Um, and yeah, so I think, and as I mentioned, hopefully I gave a sneak peek into what LangChain can do. Hopefully I gave a sneak peek into how our classes are run. This is again, I covered the content. If you didn't understand, if you didn't get anything, or if something went too fast, this is not the pace with which we would cover. As I mentioned, we would cover in around 4 hours of live class. We will have a Q&A section on throughout the week. We will have one-on-one sessions. We will have assignment sections and so on. So, but high level idea that I wanted to cover today is in a RAG based application. collect your data. In this case, our insurance LM specific documents, create our vector DB. We built our chat interface using Gradio. This is just some fancy thing that we did, nothing to do with LLMs specifically. And we can test and iterate, right? So I showed you how we can get a sneak peek into what is happening behind the LLM and so on. And all of these things we cover very systematically in more than 10 to 15 hours to 20 hours worth of content. And if that is not enough, we'll also go in one-on-one sessions or group sessions or domain coaching sessions where typically we leave no stone unturned. So one thing that I wanted to mention in this masterclass is not the pace associated with the teaching style of IK, but just the overall breadth associated with what we do. And with that, I'll open to questions.
Yeah. So to give yourself some credit, you already have some compliments in the chat, so that's okay. I think people understood that this is a teaser. This is obviously a very concise masterclass for a very advanced and detailed topic that we cover in our classes. Uh, and I have what I've tried to do so that for
Mm.
I know we are almost around 9 p.m. and we'll maybe spend 10-15 minutes to just answer the questions because people have been waiting to get their question answered. I've put them in the doc for your convenience. I'm going to share my screen. There are some that I've not put which are in the Q&A section, so we'll come back to that anyway.
Okay.
So let me share my screen. Yeah. So these were towards the start of the session. I've put all of them together with the names of the people who have asked. You can Some of them you might have answered already. So we can start with in the cost wise, how RAG is more efficient than the training model.
Yeah, so RAG is more efficient than training the model because in all, if you notice, like in my Colab notebook right now, there was a sign popping up, right? You are using a GPU, but you have a GPU session, but you are not using a GPU. So um, uh, do you not want to use a GPU? That was Google telling me that why are you using a GPU for a RAG-based system when your system is so simple? On the other hand, if I was training a model, I guarantee you that Google wouldn't have said something like that. Google would have been like, yeah, 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 please buy more GPUs and spend more money. And why is it more? Why does that happen? That happens because in a RAG-based system, you are not touching the LLM. You are given an LLM and you are using it as is. On the other hand, in a fine-tuning setting, try to try to tune the model again, and because you are changing the weights of the neural network, because you are changing the weights of the transformer architecture, that you're going to retrain billions and trillions of parameters again, or allowing them to change at least a part of them. And so that's why RAG is more efficient than training the model. Now, that being said, it's just more efficient on the training side. In fact, it introduces a lag and latency on the inference side. So in a RAG-based system, your responses are slower because your prompt goes through this vector DB, does all of this journey, and then appends the context and then produces a response. As opposed to in a fine-tuned model, it quickly goes to the LM and gets the response quickly. So those are pros and cons, but hopefully that answers the question. So cost-wise, on the training side, RAG is more efficient.
Right. Next one is how RAG is different to AI agents. I think you did answer it. You want to if
I didn't
just
answer it.
quickly even go through it. Yeah.
So yeah, and, AI agents again. Agents. What are agents? Agents meaning LLM plus tools. So if your LLM has access to tools, that's an agent. RAG is a paradigm, I think. So
Okay. Next one is so is RAG does RAG is in RAG no need to train model, just eternal data access will be enough. Vishnu wants to know.
yes, I mean that's the whole premise of a retrieval augmented generation system, which is that you are essentially skipping the training part but appending more and more knowledge externally so that you can avoid the training. I'm sure people have tried to fine tune the model and also set it up with RAG, and those experiments and iterations are still ongoing. I I myself haven't tried that, but I have read a research paper where they were trying to understand the pros and cons of fine-tuning versus RAG, and essentially it's very much an open research question still. But yes, initially it is one or the other. So if you have a RAG-based system, you essentially are going to use a pre-trained model as is with
Makes
external
sense.
data.
I'm going to try to decipher what Rahul wants to ask here, but if you could also, do a better job than me. Uh, if this RAG is analogous to tools user in agentic AI, if
Yeah. So is this RAG, is it analogous to tools user in agentic AI? Not exact. So I think the question is that is a RAG-based system analogous to tools in an agentic AI framework? I don't think so, because I think tools in an agentic AI framework mean very specific things. Um, One, you may think that vector DB is a tool which you are appending to an LLM, and so you can think of RAG as an agentic AI framework. But that's why I said this retrieval augmented generation thing is a paradigm. It's a philosophy that people are doing. This how did this name come into place? It's not a scientific phenomenon. We have just appended certain puzzle pieces, assembled them together, and so we are retrieving information from this vector DB, and so this retrieval part. We are augmenting this with the prompt, and so the augment part, and then we are sending all of this to the LLM to generate a response, and so the generation part. Is this agentic AI? In the broad sense of the term, yes. But typically, what agentic AI refers to is LLM with access to certain APIs like Google Search, Google Flight Search, Tavili Search, Weather API, Slack API, LinkedIn API, and so on. RAG, on the other hand, is this pre-trained model with some external vector DB and a combination of that. So it's similar but not analogous. So I would answer that question.
Cool, thanks. We have four questions down, and I know you have answered some before while I was talking during the session. We'll try to cover for the audience, this is for the audience, that we'll try to cover as much as possible, but we also know it's 9:15 Friday evening. We want you to get back to your work or family or whatever your plans are, but we're going to try and answer most of it, right? So quickly getting to the next one. Can I build RAG solution without vector DB?
Can I build RAG solution without? Um, I I mean, you can, but I don't think it would be the most efficient in retrieving the correct chunks. You can, but I don't think I would recommend it.
Okay,
So I would answer it with a no. I don't think. I think you need some sort of a vector DB to do the retrieval part very well. Because if the retrieval is wrong, then why even have a RAG-based system? Then might as well just send your input directly to the LLM.
makes sense. Next is, can we use RAG-based system to develop AI model that would suggest stock-based on market prediction?
You it's again, like, these are very open questions. These are good questions, but I think these are very open questions. You can use a RAG-based systems to develop stock prediction an agent. Again, it's going to be something like where you're going to, how would I design it? I would essentially take a powerful LLM, then I would retrieve all the docs from Yahoo Finance, Barron's, Wall Street Journal, and I will set up a pipeline to digest all of those docs every day. And then based off of that, I'll essentially try to collect some top 20 performing futures associated with companies, and then summarize a list for those stocks, right? So yeah, I mean, you can do that.
Okay. Next one is, can a RAG-based bot be used for specific segment or document, or it can be used for any domain of knowledge? Neither depend.
Yes, it can be used for any domain of knowledge as long as it's the retrieve. This is a very generalistic framework. So the retrieval part and the documents associated with the retrieval, if those, as we constructed in this demo, this ensure LM company specific documents. As I mentioned right now, I can create a financial bot that just consumes financial news every single day or every single hour. And that's a very different domain than this insure LM company specific documents. So yeah, you can totally do that.
Got it. Ankita has a question. Why not attaching RAG with prompt engineering? And this was, I think, towards the first half of your
Yeah, so I
presentation.
think prompt engineering, what was the other thing in there? There was some memory management. Um, um, all of these things are different pathways to reduce hallucination in LLMs. And in fact, we did do a little bit of prompt engineering in our demo as well, right? We in that system level prompt, we mentioned that if the information is not available in the database, say, I don't know, maybe another way to do the same thing is to, instead of saying, I don't know, maybe I can create a loop or a if statement or a if branch where if the answer is not available in our retrieved documents, just go directly to the LLM and produce whatever thing you want to produce. Maybe I want to do that. I don't know. So that at least I'm giving some answer. If it hallucinates, it hallucinates. But
Mhm.
it's up to me. And so we did do a little bit of prompt engineering in our example right now. So you can absolutely match prompt engineering and RAG together. In fact, people these days do agentic RAG, which is what I was saying, which is prompt engineering, LLM, access to tools, and access to vector DB.
Yeah. Moving on to the next one quickly. Explain how we can give relational data in Excel as RAG input.
So there's a library called LangChain. I'm looking at the exact name, CSV loader. So there's a LangChain CSV loader. You can essentially use a CSV loader and chat to. So I pasted a snippet of code in the chat. You can essentially do something like that to create your data loader from a CSV file, and I think that's how I would use a Excel or file for RAG based systems.
Yeah, makes sense. Thanks for that, actually. Uh, Aditya is asking, RAG pipeline can be created only for pre-trained model?
You can create a RAG based pipeline for any, no, actually, you can. So as I mentioned in the code, the LLM, it doesn't matter what, like you can use chat OpenAI to get the GPT based models. You can use Cohere's Mistral, the French LLM company. You can use their models, or you can use your own Llama models from your own local computer. You can just load the safe tensors, the PyTorch tensors associated with the Llama model, and load the LLM in a variable in Python and pass that LLM to your LangChain model as well. So it doesn't need to be pre-trained. It can be your own LLM that you designed and fine-tuned, and then pass that to the RAG-based system. Uh, LangChain wouldn't care about that. LangChain would just care about some language model that you're giving to it. And again, RAG is a paradigm, it's a philosophy. So you should just think about RAG as three or four core pieces: input prompt, vector DB, some language model, and this output processing memory context. And you can essentially mix and match any of these four pieces whichever way you want. Nowhere in the RAG system it says it should be a LangChain based system. I could use N8N. I could use LangGraph. I could use my Golang or C++ if I want to. RAG is a paradigm. It's a philosophy, and so yes, you can use RAG with pre-trained or closed source, open source, fine-tuned model.
That's an amazing answer, actually, Surit. Thanks. I think this you went into a lot of detail, how to enforce constraints in RAG. I think we covered this
Yeah.
a lot in detail. This came obviously a little towards the middle of the presentation. But if you want to just, if your choice, if you want to just add something to whatever you explained.
So, yeah, I think enforcing constraints in RAG, you could do it a few ways, right? One thing is through prompt engineering. In the system prompt, you mentioned that don't answer anything that you don't find in the vector DB. The other thing is you can isolate the documents in your vector DB itself. You can essentially constrain um, a lot of which documents enter the vector DB, which don't. Pinecone, which is this one of the vector DBs that I'm familiar with. Pinecone has a different type of access control. So let's say in the HR type of a setting, you may want to hide the personal information, birth dates, performance reviews of companies in your RAG-based system, but also give employees access to company-specific information, right? Like profits, financial reports, and so on. You can set role-based access control, RBAC control, for example, in Pinecone-based systems, and that's how you can enforce constraints on the vector DB side itself so that only those documents are retrieved which have the permission and the classified documents are not retrieved, even though the answer exists, for example. That's one way. Prompt engineering is another way. Um, yeah, but if there's another method, I'm sure that you can modularize that and code that up. But that's how I would enforce some constraints.
Okay, thanks for touching on that again. Next one is, and I'm going to try to direct you towards the part of the question that Neeraj wants an answer for. Can a same RAG-based bot system be used only for a specific domain of a document? And you read the second part of the sentence, which is example, a RAG-based bot designed to read and understand the legal document, and it can be used for any non-legal or general document also.
Uh, you can, as long as, I mean, so there is something known as precision and recall in the machine learning world, right? Which is you you want your system to retrieve a narrow set of precise documents, um, true positives, which means, and you want your system to only retrieve those true positive documents based on your input query. Now, if your vector DB is going to contain information about company documents, financial information, and some food recipes also, I mean, it's fine. Hopefully, your questions and input prompt are very different such that you can ask a question about company specific documents and how to make pasta, and I think both of those will be retrieved fine. I think you can do that, but typically RAG based systems are designed to have like a very domain specific knowledge, domain corrected thing. So if you are using a legal document, legal knowledge based RAG system, it would be easier for the LLM. You can use a less powerful LLM, you can use a less powerful vector DB and keep it all constrained within this legal framework to answer only questions based off of that. If you want to answer questions which are like something about travel itinerary and food recipes and legal thing and some company specific docs, you just have to get a more powerful LLM and spend more money.
Awesome. Uh, I know we are obviously, we are short of time, but I'll pick up maybe the last two questions if that's okay. I know we have not answered everything, but hopefully when people look at the video of the session on our YouTube channel, they will be able to, pause in places and re-understand things that you were trying to say. So I'm going to pick one which says, what kind of data structure can be stored in vector DB for RAG to access? Like only text files, CSV files, like structured data, or any kind of data like a PDF or image screenshots? Aditya wants to know.
It can be all multimodal data. These days, Pinecone, Chroma DB, files, they all do images, audio, video, text, because all of them are essentially converted to this mathematical representation of a high dimensional set of numbers. You can think of that as an array of numbers. So at that point, for that vector DB, it's just an array of numbers. It doesn't care about if it's a audio, video, image, text. It's just a set of numbers for it. So you can essentially do multimodal data storage.
Yeah. One question, can we create, there were a couple of questions around this, so I'm just picking this one up. Can we create vector DB on local machine, or do we have to use a third-party service? And I think this comes from a security angle also.
Yeah, so I think we there are open source access tools for creating vector DBs on local machine. I haven't used one specifically myself because in production settings, I'm not in cybersecurity. Typically, I have relied on Qdrant and Pinecone, and I do think they have, like, if you take their paid membership, like the subscription membership, there's like they don't train on. They claim that they don't train on your data. They don't like touch your data and so on. So I think you have to get that specific commercial license for them. But I haven't played around with setting up a vector DB locally, but I think you can.
Okay. Last question, difference between RAG and MCP. Just kept this for the last one. I think great question to understand basics and stuff about agentic AI also, which everybody was interested in.
So so I'll answer RAG first because we just talked about RAG, so I think it's a good thing to summarize. So RAG essentially grounds your LLM in a particular knowledge by setting up this external data source. And so the primary purpose of a RAG-based system is to ground the LLM in knowledge for better responses. So the question that a RAG-based system answers is, what information should the model see? What information should your LLM see? That's your question that the RAG-based system is trying to answer. Your model context protocol is the primary purpose of MCP is not knowledge injection into the LLM. The primary purpose of MCP is to enable tool and context interoperability. So how does a particular model access external capabilities safely and consistently? So how can you like not tweak the code and the APIs every single time if you are changing from one model to the next? That's what MCP does. So it's like it handles if you are connecting the weather API, if you're connecting some LinkedIn API, if you're connecting Slack API, all of these APIs, if they have a JSON response, HTTP response, there should be a layer that connects all of these responses in the same way to your LLM, right? And that's what MCP does. So MCP, they're in a way different things. They're used for solving different questions. MCP is for enabling multi-agent, multi workflow situations and simplification of that. RAG-based system is essentially for knowledge injection and reducing hallucination. I hope that answers the question.
Yeah, makes sense. I know we have not covered a few questions, but that always happens. That's why we keep doing these master classes. If you feel that some of the questions are not answered, uh, please join our next master class, or better yet, join our program and you'll actually get answers to everything in the next 3 to 4 months through actually working on it hands-on. Right. So I would like to take an opportunity to thank you for, I know it's super early for you. For people who don't know, he's joining us from the US time zone, and thanks for doing this so early in the morning for you.
Thank
And
you.
going through every question. I know we have not answered everything, but hopefully, like I said, go to our YouTube channel, Interview Kickstart India, and check out his video again. And he'll take you, you can pause and replay and take as much time to absorb it as possible. Right. Thanks again, everybody. Have a great evening ahead. Have a great weekend ahead. Thanks, Surit. Thanks so much. Bye.
Thanks everybody. Take care. Bye.